For RCR TV, I'm Sean Kinney, and welcome to HetNet Happenings, where we take a look at all things DAS, small cell, Wi-Fi, and much, much more.
Nexius, accelerating network and business transformation.
Telecom Careers, the #1 global telecom and wireless job board, telecomcareers.com.
Welcome back to HetNet Happenings. We've got a great show for you this week that continues our in-depth look at some of the technologies that are likely to shape the 5G mobile networks of tomorrow. Right here in RCR's backyard of Austin, Texas, National Instruments hosted their annual NI Week, and we got a chance to take a look at some of the 5G aspects of the exhibition. As I mentioned, 5G has yet to be standardized, so there's not really a clear definition of what the technology will entail, but we did have the opportunity to speak with James Kimmery, Director of Marketing for 5G and SDR at National Instruments, to get his take on it.
Well, 5G has many definitions, but I think in general it's the next generation of wireless. What is the next thing? It is the next thing that our wireless networks will migrate to. And so I think one of the things that I think makes 5G special is, and reason why a lot of people are talking about it, is because if you look at our current networks and the progression from 1G, 2G, 3G to 4G, I think, and then 4.5G, you can see that the technologies and the roadmap was fairly well defined. You know, from 1G is analog voice, 2G is digital voice, 3G was about some data. I won't say that it's mobile data, about some data. And then 4G was really about mobile broadband data. It's where actually mobile data was really useful. And that's what opened our eyes to, wow, what if our networks were more reliable? What if they were faster? What if they could handle more capacity? And then, the possibilities in terms of applications over and above what smart devices can offer, it's really astounding. So I think, when I think about 5G, that's a long setup there, but if you think about 5G, it's that next step in our networks that kind of break away from kind of the traditional 1G, 2G. It's about addressing things like lower latency, better having responsive networks, or predictable response, more capacity, higher data rates, of course, but also power saving. I think once the technologies are available that address those, then that's 5G.
In that last clip, James mentioned that before we really know what 5G is going to be, some of the technologies that are going to support it need to advance. Among those technologies are massive MIMO, which is multi-input, multi-output, and then millimeter wave, which would open up high-band spectrum for cellular use. In this next two clips, we're going to take a look at the work that National Instruments is doing to support its clients' work on developing those technologies.
So this is our massive MIMO demo. Over here on this video is showing off the 100 antenna system that we deployed with Lund University. And we didn't want to be able to bring 100 antennas down to the demo floor, so we have our mini version of the massive MIMO. And it's running the exact same code that's on the 100 channel system. And what we have is these two users that are connected to these two USRP RIOs, and they're streaming some live video and some random noise as QPSK and 16-bit QAM to our base station. And all of these antennas are synchronized. And other important things, this is all 20 megahertz of real-time bandwidth. And all of the encoding and decoding and modulation and processing is done on the FPGAs of the devices themselves. And so one of the things that we can do is, if I mess with this antenna corresponding to the video, there we go. We can see that the video starts to drop out. And as I return the antenna back, our constellations look all nice. Video returns. So just showing off that the USRP Rios are live UFPGA programmable. They have 40 megahertz of real-time bandwidth. Yesterday we just announced officially the 120 megahertz of bandwidth versions, and programmable through live UFPGA for additional kind of research as you so choose. I think that you can kind of take this code or our application frameworks in LiveView Communications and kind of replace the modulation sub-VI with your own version of, like, say, what you're trying to research for 5G, or kind of change out small pieces as you see fit. And so with that framework, they give you all the code to do everything, and then you can kind of just tweak things as you so choose.
My name is Matthew Krimple. I'm in the RF software team at National Instruments. And here we're showing one of NI's systems for prototyping millimeter wave research. So what we have here is a demo of a system that has up to 1 gigahertz of bandwidth. Right now we're showing just the baseband portion of that. This is a system that was developed with Nokia. So in that system there were additional RF up converters, RF down converters. Right here we're just showing the baseband portion of that. So what we have is a generator right here and an analyzer right here. The same thing on both this system and this system. So right here we're just doing a loop back from the generator of this chassis to the analyzer of this chassis, and then the same thing from this generator to this analyzer. So yeah, using this, customers could do whatever that they need to do to evaluate the millimeter wave portion of the spectrum. Though in the current regions of the spectrum that are being used for communications, the 2.4, 5.8-ish areas, starting to get more and more crowded. By moving to these very high frequencies, these millimeter wave regions, there's much greater bandwidth available. So this system would allow for 1 gigahertz of bandwidth. In keynote this morning, there's another millimeter wave system that NI has put together using all NI hardware that supports up to 2 gigahertz of bandwidth. So more bandwidth is better for more data.
Now, during NI Week, James moderated a panel regarding 5G and some attendant topics that was one of the more interesting panel discussions I've ever seen, and that's sort of a ringing endorsement because I definitely spend 25% of my time watching panel discussions of this nature, and this one was really, really interesting. But before we take a look at the panel, let's get a preview of the talk from James.
So what that means is I haven't prepped these guys at all. I did that on purpose, just so that you know, I wasn't lazy. I haven't prepped them, and I've given them some questions to think about, but some of the panels that I've seen, not to be critical, but I am going to be critical a little bit, a lot of hear the same thing about 5G, but I want to dig a little deeper. And this is actually a really great panel with Dr. Goldsmith, Dr. Robert Heath, Dr. Amitabh Ghosh, and then Dr. Khan from Samsung. So we'll have kind of a group of researchers that we worked with, we know, but if anyone can handle that type of questions in that type of form, it's these guys.
So now let's jump right into that panel discussion. You're going to hear from Amitabh Ghosh of Nokia Networks, Dr. Andrea Goldsmith of Sanford, Dr. Robert Heath of the University of Texas at Austin, as well as Farouk Khan of Samsung. Let's listen in.
Because I'm curious what your views are on the transformational impact of 5G. So, Dr. Ghosh, if you could start off, what's your opinion? What's so transformational about 5G?
Okay, so 5G can do what 4G can't do. That's as simple as. So, in summary, 5G, as I said, would be different technology, or it will have a different impact, as we see from today's 4G technologies. All aspects of our life will be affected by 5G, from agriculture to medical, as you saw in Dr. Goldsmith's presentation, to machine learning, to machineries. Everything will be affected. We'll have massive broadband capability, as we saw in the requirement, which will provide all these great peak and edge rates, and 10,000 to 20,000x capacity using new spectrum bands, low latency applications like augmented reality, tactile internet, Gerhard's favorite thing, private, and then mission critical MTC, and also massive MTC. But I think the massive MTC part can be satisfied with the current LTE release 13.
Robert, would you like to add to that, or?
Yeah, what was the question again?
What substance?
Ouch. Okay. All right.
Hey, I just want to know, is it physical internet? Is it still there?
Yeah, ask me again in a couple of years. I guess I agree with what I was talking about. It said, but for me, what's transformative about 5G is the new applications that will enable that we don't have right now. The three I can think of, and one is this augmented reality, which I think is has been discussed quite a bit, but we still haven't seen it. It requires beyond the communication a lot of interesting processing technology as well as location. And that's a piece that's been missing that I think is now being solved, so that we can.
The location piece.
Yeah, locations that we can overlay on the scene that we see in front of us here. We know where everything is, and we can put virtual things in their proper place, right? Like I can have you sitting down in this chair here, and I have to know very precisely where that chair is, so it's, I can render you correctly where I am. And I think that's something that's coming available now. That's also going to be leveraged by 5G. And then I think virtual reality, especially for gaming, is also starting to really step up now. You're going to need wireless to get the data to that headset. And then the final one is transportation, where I think the vehicles, especially for automated driving and even the serious driver assist that we're seeing right now, is going to be able to leverage a lot of data from other cars, and that's going to need 5G to get high data rate, low latency. So.
How about Farouk, do you have anything to add?
Yeah, sure. So what Mitama said and Robert, my company also, we say, for example, Gear VR, virtual reality is the headset from Samsung. So my team came up with that one, and it requires 10 times more bandwidth than a 2D thing. But my view about the transformation really, if you look at the growth of the internet, mobile internet, in the beginning, the growth was 80%, and now the growth is 8%, including the mobile. At 3 billion, when we reach the 3 billion users worldwide, it's not increasing. It's stalling there. So what about the remaining 4 billion people, remaining 60% of the humanity? So this is what motivated us, looking at 5G as a transformative technology. We have to bring the cost down. That was the reason. If you think millimeter wave is a bad idea, you can blame me for that one. I started that, and the reason I think Sandeep already covered that. Why spectrum needs to be so expensive? Why I need to pay 65 megahertz, $45 billion? We identified 252 gigahertz spectrum. The only nature preventing us is the oxygen absorption and the water vapor absorption bands. We have 250 gigahertz spectrum available. So why we can make it cheaper enough to make it available for the 60% of the remaining humanity? And the things like the in-band backhaul. Once you have millimeter with so much spectrum and the direction transmissions, the backhaul becomes almost free. Why we are not looking at these type of technologies, and why we cannot just make it so low power? That's another big focus area, that we just rely on solar energy. So then what is a base station? It's a cheap piece of hardware I can throw in anywhere. It has a self-backhauling, self-energy, everything. Then we are talking about we can go and cover the remaining 60% of the humanity. Then I can claim, this is what is transformative about 5G. Otherwise, yeah, we have all the virtual reality, great things, Internet of Things. They would be happening, but they have been happening already with 4G. Yeah, but go look at, 3 billion stored, there's no more growth, and the cost is the showstopper there. We have to bring the cost down and look at these disruptive technologies.
So it sounds like Farouk wants to mess up your business on the top.
Well, okay, go ahead.
Well, actually, I'm going to disagree a bit with Farouk about the cost, because I don't think the millimeter wave devices are going to be cheap, at least not anytime in the near future. So I don't view the millimeter band as a way to bring costs down. I think there's other ways to bring costs down. And actually, when I think of, now, first I want to clarify what we mean by 5G, because is it going to be the first, is it 3GPP's next release? Is it, several releases down? So in my mind, I think of 5G as kind of the next generation of cellular networks at the edge of how those evolve, because I don't think we're going to be getting to 10 or 100x data rates in the next release of 3GPP. It's going to take a few iterations. But looking at that as the definition of 5G, I think what is going to be transformative is the fact that these next generation networks, they will evolve smartphones, so I don't think there's going to be a revolutionary change in smartphones. We'll get better data. But it really is the Internet of Things that these networks have to support at low cost and low power. Because, the cost model has to change. If my tennis shoes are connected to the Internet over LTE, I'm not going to pay, for the data in the same way that I pay for the data on my smartphone. So we're going to have to make the pricing structure of the networks change, which means that the cost of the networking has to change. The power requirements for the devices have to be far, far lower than they are today. And I think that that's a challenge for, even when I look at what's being proposed for 3GPP next generation releases, they're not really focused so much on how do we get these low power networks. If we can get what I define as 5G, the ability to support these low power devices in a cost effective way, that is the revolution for the Internet of Things, which actually I think has the potential to be like the next wave of the Industrial Revolution. I think the potential for monetizing all these sensors and processing the data with them is going to drive basically the next wave in economic growth.
So based on what we heard there, 5G really does have the potential to transform not only the way that advanced nations interact with technology, but also the potential to bring the 4 billion unconnected people on Earth into the mix. So that's a really exciting topic. And for more on that panel, I'd encourage you to tune into the whole discussion, which is hosted on our YouTube channel. For lots more content from NI Week, you can check out rcrwireless.com, as well as our RCR TV webpage, and as I mentioned, the RCR Wireless News YouTube channel. I'd like to thank the folks at NI for putting on a great exhibition, and thank you to the folks at home for tuning in. We'll see you here next week on HetNet Happenings.
HetNet Happenings is a production of RCR TV. To reach Sean Kinney or to suggest a show topic for HetNet Happenings, you can reach Sean at skinney@rcrwireless.com, on Twitter at SeanKinneyRCR. To find out more about the latest in HetNet and all things wireless, dig into rcrwireless.com.